Is it this one? Ah, yeah. And what's more interesting, I need iTerm. What? Okay. Let's. Is it fine, right, to mess?
David, give us your impersonation of Donald Trump.
What?
Give us your impersonation of
No. I'm an anarcho-capitalist. I don't care about government.
Yeah.
I just would like to see
No,
what
Windows.
say.
Really? Yeah. So let's see if translation is working. This
Something.
YouTube's.
YouTube's.
Oh yeah, it's working.
It's working now.
It was showing the stuff. So okay. Yeah. Let's hear from me about it.
How vain you
Yeah. Some like basic stuff because let's say when I started using Git, it was really easy to start comparing with all other like SVN and the previous version system. It was really easy to work with and how to say to interact with. It was quite nicely. And using it for a while, I realized that it actually helps a lot to know how it works internally. Not only how you can interact with this like so-called front-end commands, like git add, commit, or whatever, like to just store the files in the system, but also know what happens inside the Git itself. So I'm gonna talk today, but since it's kind of a quite big topic, I will talk only about objects, how Git organizes file storage internally. Yeah. So let's dive into like before we actually go into details. I will just first talk briefly, because I think everybody, even if they didn't touch, but at least heard the Git. It's yeah, used for tracking the version, so to say, mostly used by developers because we work with files, like text files, and we always want to store some file snapshots and then go back in time, back and forth to compare like changes that we add to those files, and and having such system as Git or like Mercury or like whatever the system you're using helps a lot to organize the development. So Git is like powers a lot of as Mitsu once said, cloud services. So in this case, it's GitHub, Bitbucket, GitLab, and like dozens of others, like Perforce, for example. Yeah. So how it works? You have a directory where you have files. Then when you want to add files, you use like add command. And in this case, the copy of a file that you have in the working directory will be added to the index. And you can like do this like all the time. But when you make some changes to the file, you can always use add command, and it will copy again changes to this index staging area. And whenever you want to save this state in the repository, you use commit, usually with the message. And automatically Git will store like author and the message and create this like a commit snapshot with the like with the files that references in this commit. So like you can always go back, and then you can always like for example go back, reset the current working directory to the previous state. You can work with remote repositories and so on. Like you can merge like references. We call like branches. But I won't be mentioning it in this talk. I want to do it like next talk specifically for references and for more or less like low-level interaction. Yeah. So like let's just type some commands. It's like really simple, like create repository, add a file. So, where was it? give me item. Yeah. So we have air talk, like for example, I create a directory. It's empty, and I initialize a repository, and it now have a .git. So everything is in, well, all the files that Git needs will be stored under the .git directory. Then let's look inside. What does it have? Yeah, so it has like a lot of default scripts that you can always like hooks for some commands that you have. I've been not mentioning this installed. And then it also creates special directories. So let's see, for example, create some file. Like we have a file, and you can see that it's not added. So using add command, we actually add file to the staging area, so to say. So it's now tracked by Git, but not saved in it yet. Yeah, and then we can actually see before commit happens. So we see that it created a new object. It's actually added the file. And now we can save our state, like, and it, whatever. And yeah, so in this case, we can actually see it in log. We can see that it's now clean area, and we can also see that there were more objects now written. What the heck is this? Will be explained soon. Yeah.
Stay tuned.
Yeah. So I just prepared it. Okay. Yeah. So as I showed, there was 3 files that was added to repository, and basically now we are looking under the hood. Yeah. So I already did this. Like I created another clean repository because it's easy to work with like clean states. Yeah. So looking at this directory with Git objects and reading it a little bit like how it works internally. Actually, Git have 4 types of objects that it can store. It's blob, tree, commit, and special kind of object is a tag. I will not be mentioning tag because you need to know references for this. So like branches and so on. So in this case, I will omit tag for now. So what Git, like in general, what it is? It's like in a nutshell, it's a key value storage. So you can always put some content in it, and while you're doing this, it will calculate some ID. In this case, it's a SHA-1 hash, which you can use later to get this content back. So it's like a normal key value data store. Then everything is an object. Object is compressed with a zlib deflate algorithm. And yeah, as I mentioned, it has several types. So to be able to interact with it in a low-level way, Git provides 2 basic commands with it for this hash object and cat file. So hash object creates new object, like any object of any type, and stores it in its own like Git objects directory. And with a cat file, it can retrieve it back using this SHA-1 hash as a key. So it can show the content of the file or like type or whatever in this like the object file. Yeah. So let's start from like blob. Yeah. So it's yeah, blob. So blob is type of an object that you used to store some like file content. So it's no file name, nothing, only content. Yeah. So we use hash object. Nice. Salah has completion. What? Ah. So we add now. You can actually see it manually. We edit object manually, and yeah, it returns some ID. Yeah. We can actually use this ID and cat file. You can print it out back. It's pretty easy. So let's try it again with a bit interesting version. This one, and now since we're using file, we write it and create another one and edit it again. So let's see, for example, this one. Or this one. It's like both are blobs. And yeah, let's start here. So this is a file which has a test. So actually, at this point, for example, we can already interact with it doing something like this. So in this case, it's how Git works when you change between commits. So it deletes all the files in a working directory and puts them back using whatever reference it has. But of course, this is not convenient because you always have to remember which was it? Like some hash. Yeah, for example, this one. You can use. I can control that. Yeah. So and so on. So like you can always go back and forth, but yeah, it's not practical. But, for this reason, there is another thing which is called tree, which is a basic like the most like core structure that actually allows Git to be like good version control system. So tree is a collection of two types of references. It can reference either blob or another tree. So in this case, you can always like recursively add trees into it, and this is how directory structure is organized. Git doesn't store directory anywhere, but only as a reference here. So if you have it's like it has a special format. So it's basically it's a text file, a compressed one. So is there a special mode to see what kind of file is it? Is it executable or just a readable or a symbolic link? Then it's a type, blob or tree. Then the IDO of that file, and then the name. It could be the file name or directory name. In this case, if it's a directory, it should be tree. If it's a file name, it should be blob. It's like pretty straightforward. Yeah, and that's where the file name gets stored. The blob only stores file content. Yeah, so to be able to work with the trees, you need to use a staging area. So Git provides this binary storage, which of a special structure that I'm not mentioning. It's quite huge. So basically, when you use git add command, what it does, it actually runs under the hood these two commands. It first calculates a hash of each file, and then adds them to the staging area. And from that, it writes the tree object. It's like pretty straightforward. Let's try. Yeah. Okay, so we have the index, the one that we already have. I mean, this is the mode, like the file itself is readable. Then add the first one. This one. Ah, yeah. So it was test. I think text. Then git write. So we get something back. Right? Let's look. So you have one more object added, and now we can actually use this reference to see what it is. File. So it's a reference. It's mode, blob, then the reference to the file content and the file name. Yeah, pretty straightforward. Then we can also where is it? Git file type is tree. Yeah. So and another one. Yeah, this one. Date. Yes. Cache. For same thing. Where is it? Yeah. And yeah, so we added to this staging area, and then add the new version of the file. Like so now it's
test in the previous one.
We
use test
because it's already added. So it's adding a new file that is in the current directory and adding a file from the previous, like already stored in the blob. See, so now git write 3 will return something again. And we can see that I have 2 files now. The new version and the test. Yeah. So let's continue. It's important. Yeah. Yeah. So actually, yeah. So like in this way, you can create like trees, so to say, and using, for example, you can also use something like this prefix and use. And using other tree as a prefix, we can yeah. We can actually add the current content with the reference, like the tree of the root, basically of the root directory. We can, using prefix, we can add it to another subdirectory. And again, like we can extract stuff from it. So it's like it's pretty, pretty useful. But yeah, the project, like it's like snapshots that you need to track and so on, but it's not practical since you still have to remember hashes for all the actions, like all the files plus trees plus and it gets built up. So for this you need to use commit. Commit is very easy, but yeah, the thing is when like you can create commit from any like from any tree. It's like a snapshot that has a reference to the tree, author, committer, and a message. But more importantly, for example, like I pre-calculated it here, but if I do it now in a console, the hash will be different because of the timestamp. Since it hashes based on the content, timestamp will be different. So using this, I can like always like create history, so to say, manually. So it's like last. Let's try.
So you can cheat with your commits.
Hmm?
You can cheat with your commits.
Yeah,
Nice,
You-
correct.
you can
You pretend that you're working.
Yeah.
you can be very bad.
You already find the truth.
The Lebanese way.
Yeah. You work, yeah, you didn't see the comments?
Yeah. It's too much work, but I don't know if it's worth it.
And then what was it? It's not convenient. Yeah. So I have first commit created. Then I can let's just create all of them because they don't have that much time. The second commit again created again commit 3. Then use parent. Yeah. Then use parent, and I need an ID of another. Was it? It's here. Of another tree. Yeah. So now I have 2 commits. So if I want to look, see, git log start. This one, second commit. I can see commit history with file edit and so on. So I can like continue, keep adding this until I get tired, basically. Yeah, it's like add more files, create 3, create commit. So this is how like Git structures, and at this point, that's where like reference come in place. So like for example, in this example, I have this like 3 commits. Yeah. Yeah. So basically, this way, like just using very low level commands, we were able to look how it works like internally. So what you need to do is like for add command, it creates ID and stores it as a blob, as an object, and updates index. So it's like 2 steps is an add command. Then it writes 3 object and creates a commit object with a reference to the tree immediately before that commit. So in this case, yeah, commit is also like a combination of 2 actions. Yeah. So I also had an example. It would be, we don't have any time for this yet. So actually, you can create this hashing, like adding objects, is also very easy manually. You can like use a script. Yeah. You create a header of a type, then combine it with data, calculate SHA-1 hash from the data, create like compress it, and write the compressed file with like to the Git object directory. And Git will can read it normally. So like I put script here, so if somebody interested in digging it, it's from a Git internals book. implementation with a bit of like command line options. Yeah. Yeah. So yeah, I want to continue like in the next talk to actually talk about references because it's important. Like once you know how it's stored and where those trees come from, knowing and understanding the references, you would be able to understand how Git is able to switch between branches and how you can merge them, and also how you can fetch, for example, changes from GitHub to your local computer, or vice versa, how you can push your local changes to the remote servers, wherever. Yeah. So I put like few references about this. I wanted to, visualize it a bit, but I need more time to actually visualize the content of it. Yeah, and basically you need just to dig in, like look at the .git directory and see, like delete files and see how it works and so on. Just like dig deeper manually. Yeah. And since it's January 20, I had to put it here. Yeah.
Any questions? One question? Actually, it seems the people behind us are a bit late, so we can do one or two questions. It's too low level. I don't think anyone has any questions about this.
What kind of companies are using this structure? Large companies, blocks, trees, like Netflix, for example.
Oh, it's Unix, for example. It's a classic Unix file system storage.
Anything, any data.
Yeah.
It's maybe high resolution. Yeah,
Yeah.
that's what I was, actually that's a good question. Though, can you, so anything that's super high resolution or something, like huge files, you can store this way very quickly.
Anything.
Yeah.
Anything you want.
Yeah. Yeah, because the goal is, I mean, of course, it would work with like huge files or like smaller files. Why it works good with Git? Because first of all, it references file only once. So you have a structure of who maintains changes, and your project directory, like working directory structure, is separate from the actual file content. So in this case, all the changes you can track independently from the file itself. So file is stored only once, usually, and it's also compressed. So if you're able to compress even huge files, in this case, it would also work with big storage. But since the original creator of Git is Linus Torvalds, who is also a creator of the Linux system, the file system in Git is a simplified version of the classic Unix file system.
Where's the major problems with it? Like, what are some of the really pains that you could see arising out of using like systems? Like
Well,
The worst thing on a file system is actually to know where to write, because on a hard drive, you don't want the how do you call it?
shit everywhere.
Yeah, so you don't want to
Fragmented.
too fragmented and to take too long to actually read the file, because a file is not going to be contiguous on the drive, and so you don't want to have something there and something there. Yeah, it's going to take too much time to actually access it. That's the worst part. Actually.
And how do you prevent it? What's the?
You have a ton of algorithms to do
Yeah.
this, but it's hard.
it depends on the file system implementation.
Would you have to use this for big chunks? Sort of structure.
No, because it's low level.
Only if it's giant chance.
Yeah.
Giant chance.
Because if you use S3 storage, probably behind, like under the hood, they also using something similar to this.
Sorry.
So if you don't have any what's it called? If the files aren't compressed in Git, if you delete files from your directory will actually grow, right?
Yeah. Well, but it also would grow even if you delete it from your working directory. As long as Git have reference to the blobs, it will keep this file in the .git directory.
Yeah.
So if you add, for example, if you add a file but never commit it, it will only stay in your local repository. But if you add a file and then create a commit, in this case, and worse, you send it to remote repository in the GitHub project. In this case, everybody, when they will be taking changes, they have to download this huge file
What
even if it's not used.
what attracts you to studying how this works? Like, what
That's a designer question.
What attracts you to this?
Because everybody should know how computer works.
Okay.
Just say I'm Denis.
Basically, like it's being familiar with the tools you use.
I think it's totally cool. I'm not making fun of you.
No, it's actually easier if you know everything at the low level.
Yeah.
Because everything looks. After it's boring actually. Because if you know everything at the low level, it's like fashion. Every 2 years there's something new that you already saw like 10 years ago, and it's exactly the same thing or slower. And in the end, this is always like a few system calls, writing and reading, and that's all.
Like what? The reason why I asked that too is like, are we done?
The notes coming.
Okay. Well, it's like how what do you do after it? How, career path wise, like what you are interested in next? Software development, hardware development. Like, it determines like other things, like our innovation.
What would you do next after you figured out how to do this?
We'll go study something else.
Yeah, right. But what?
No, it's more like it can give you ideas of the
The more you know, the more, and also saves you from surprises.
Save me first.
Yeah, because like you get the code, and you don't know, like you have for example several branches, you merge them, and you have no idea what just happened. If you don't know like how it internally manages files, you might have a, for example, problem that you accidentally delete branch, and you want to recover it. You want to recover some content.
So when they call it a tree, is the metaphor like literal? Yeah. Tree. Okay. I just want and that's how you would think of this structure too, or a book.
No, it's a
never
tree
any
structure.
book. This tree structure.
Yeah.
Thanks.
Cool. All right. Thank you. Thank you, everyone. So for next time, I'm trying to make an integration from YouTube. So as soon as the stream goes live, it'll send us a notification on our Slack and stuff like that. It should be easy, but I'm just working on it today. And other than that, any feedback that you can think of right now?